Let's talk about permutations. Permutation is essentially an ordered arrangement of a number of objects. Now, let me give you an example. What if I have three letters A, C, and D, and I want to order them around? These are the 1, 2, 3, 4, 5, 6. 6 possible ways that I can order these three different letters A, C, D. So this you count, you exhaust them, you list them, the answer is 6. Now, the whole purpose here is for us to do it mathematically and by calculation rather than just listing. Because you can think about it, if there are three numbers A, C, D, what if I have A, B, C, D, E, F? If there are G, let's say 7 different letters, I'm quite sure you don't want to list them out. Alright, if you have 3, we can list. If there are 7, I don't think we want to list. Now, what if you have A, D, and D, right? Then by listing out, it's quite easy. You have A, 1, 2, 3, 1, 2, 3 only. There's no other way to do it. There isn't a fourth way to arrange them. But the question is, how do I find the total number of permutations for 3 letters out of which 2 are the same? So this is what this whole chapter is all about. Alright, don't worry, let's get into it. Suppose I have 7 distinct objects, 7 very different objects, right? Distinguishable, they're different. How many ways can we arrange 3 objects in a row? In a row like that. So here we're going to make use of what we learned earlier, which is the multiplication principle. How? Because the first slot that I can put in, there are 7 different choices. The second slot, there are 6 different choices. And the third, after you have eliminated 1, 2, then you are left with 5. Then this is the third place, you have 5 choices. Now, as I said just now, you use the multiplication principle. Why? Because these are done successively. That means one after another. You can't plus because they are not mutually exclusive. You choose one followed by the other. So that is the number of ways that we can arrange the 3 objects out of 7 distinct objects. Now, is there a formula that we can use? The answer is yes. Let us suppose I have n different objects. Now, instead of 7, I have n different objects. Alright, and I want to choose R out of n. I want to choose R to arrange. So, you have first place, second place, third place, all the way to the rth place. Obviously, R must be smaller than or equals to n. First place, there must be n choices. After you pick one, it could be this one, right? It could be number 4, it could be whatever, it could be this one, right? It could be this one, I have no idea, right? But doesn't matter. Once you pick the first one out, you are left with n minus 1 choices. And then you pick one more, you're left with n minus 2 choices, and so on and so forth. And obviously, you are going to multiply them all together. Why? Because these are successive operations. So, the formula goes like this. It's therefore n multiplied by n minus 1, n minus 2, all the way to n minus r plus 1. Right? N minus r plus 1. Why? Because if the first place is n, then the second place is n minus 1, n minus 2, right? And you must minus r minus 1 because this is the rth place. So therefore you get this. Now, if I manipulate it a little bit, if I multiply numerator and denominator by n minus r factorial, right? N minus r factorial, nothing, I just multiply by 1. Now, what do I get into my numerator now is n minus 1, n minus 2, all the way to n minus r times n minus r factorial. And this one would mean that it is n minus r minus 1 times all the way to 3 to 1. Which means the numerator now becomes a simple n factorial. Your denominator now is your n minus r factorial. If you missed it a little bit, if you're not very sure, never mind, don't worry. Most of the time, all you need to do is to press the calculator that in order to arrange r places out of n possible distinct objects, the formula is just npr. This and this are used interchangeably. And good news is later on I'll teach you how to find this using calculator. So essentially the NPR notation is basically the number of permutations for R objects out of N distinct objects. Remember just now we talked about the 7. If we talk about the example says 7 distinct objects, correct? In the earlier example 7, how many ways can I pick 3? Alright, which is actually 7 times 6 times 5. This is actually 7p3. Right, so if you see NPR, right, it's the number of permutations to arrange R out of N distinct objects. So either you say 7p3, if you have 7 distinct objects to arrange 3, or you want to arrange 3, or you, of course you could take 7 times 6 times 5. These two will end up with the same thing. But now we're talking about small numbers. If you imagine if I have 200 objects, I want to arrange 10. I don't think you want to take 200 times 199 times 198 and on and on and on. So you will say 200 p10. So far so good. So the formula, how the calculator calculates it, is basically this n factorial over n minus r factorial. From this point onwards, we assume that you know a y's like that. There are two special cases that I want you to take note of. One is what if r is equals to n. Basically what I'm saying is, if for example I have 7 objects, alright, where n is 7. Now I want to arrange the 7. I don't arrange 3, but I now arrange 7. How many ways can I arrange 7 out of 7? So how many ways can I arrange this 7 in a straight line? Now, then it's quite not difficult to realize that it is actually this. You substitute your n here, you realize your denominator is just a 0 factorial, and remember 0 factorial is 1. Then you get n factorial. So how many ways can I arrange 7 different objects in a straight line? Alright, is n factorial. Right? So n different ways to permute n distinct objects. So instead of 7p7, instead of npn, we sometimes will just use n factorial to find out how many ways can I arrange 7 objects in a straight line. Another special case is how np0. np0 means, that means you want to arrange 0 object. Of course, there is only one way to arrange 0 object. It's just one way. Yeah, so there's np0. This one usually not used. Usually not used in the A-level syllabus. Alright? With that, how many ways can you arrange n different object is just one way. Like I say, it's usually not used. Alright, that's it. Thank you.